If you could set foot on the different planets of the solar system with a specially designed spacesuit, what terrible fate would await you? Our journey begins at Mercury, the closest planet to the Sun and also the smallest planet in the solar system. This is a harsh world with a crater-filled surface and no protective atmosphere. The temperature range here is the most extreme in the entire solar system. At night, when the dark side of the planet faces away from the Sun, temperatures can drop to -180 degrees Celsius, a cold sufficient to freeze carbon dioxide into dry ice. With no atmosphere to retain heat, thermal energy radiates into space at a terrifying rate. Even with the most advanced spacesuit, your body would quickly freeze in this frigid environment. The blood in your veins would begin to solidify, your fingers and toes would lose feeling, and then your entire body would become as hard as ice. But if you arrive during the day, the situation is much worse. You would face temperatures up to 430 degrees Celsius, hot enough to melt lead, zinc, and many other metals. Solar radiation, unfiltered by any atmosphere, would strike your suit directly. In this environment of extreme heat and intense radiation, ultraviolet rays and high-energy particles would penetrate your protective layers. Your DNA would be destroyed gene by gene, cells would begin to mutate uncontrollably, and you would ultimately die in agony as your internal organs are cooked from the inside out. A day on Mercury lasts 176 Earth days, meaning if you landed at dawn, you would have plenty of time to witness the temperature rise from -180 degrees Celsius to 430 degrees Celsius, a change of over 600 degrees in a few weeks. No life could survive in such harsh conditions. Second stop, Venus. Next, we visit Venus, the hottest planet in the solar system, despite not being the closest to the Sun. This is a true hellscape, covered by a dense atmosphere that creates the most powerful greenhouse effect ever known. The surface temperature on Venus reaches 467 degrees Celsius, a constant temperature day and night at the equator and the poles. This is hot enough to melt lead, zinc, and even some high-grade alloys. Its atmosphere contains 96.5% carbon dioxide, a toxic mixture that could poison you in minutes if you were to breathe it. But suffocation is the least of your worries. The atmospheric pressure on Venus is enormous, equivalent to the pressure at a depth of 900 meters under Earth's oceans, which is about 92 times normal atmospheric pressure. This pressure is strong enough to crush a conventional submarine. As you step onto the surface, it would feel as if an entire ocean were pressing down on you from all sides. Your spacesuit would creak under this pressure, its seams would begin to stretch, and its protective layers would be compressed. But the deadliest danger is the thick clouds of sulfuric acid that cover the entire planet. If you were caught in a downpour of concentrated sulfuric acid from these clouds, your spacesuit would be corroded and dissolved in just 30 seconds. The acid would eat through the protective material layers, creating holes. When the acid touches your skin, it would cause horrific chemical burns. Your skin and muscles would then begin to atrophy, blood vessels would rupture due to the immense external pressure, your blood would boil in the extreme heat, and your internal organs would fail one by one, leading to a swift and excruciating death. Additionally, a day on Venus is longer than its year. It takes 243 Earth days to rotate once on its axis, but only 225 days to orbit the Sun. And Venus rotates in the opposite direction to most other planets, causing the Sun to rise in the west and set in the east. Third stop, Mars. Our third stop is Mars, the red planet, named after the Roman god of war. The conditions here are somewhat more tolerable than the previous two planets, but still extremely dangerous and deadly. The atmosphere of Mars is very thin, only about 1% the density of Earth's atmosphere. The extremely low atmospheric pressure is dangerous, and this atmosphere contains 95% carbon dioxide. You absolutely cannot breathe it. The average temperature on Mars is -60 degrees Celsius, but it can fluctuate from -125 degrees Celsius at the poles in winter to about 20 degrees Celsius at the equator in summer. The real danger begins if your helmet or suit gets cracked, even a tiny one. The pressure is so low that water and other liquids in your body would begin to boil at normal body temperature, a phenomenon called ebullism. You would feel dizzy immediately as oxygen starts to escape from your blood. Within 10 to 15 seconds, you would lose consciousness. The fluids in your eyes, mouth, and lungs would begin to boil, forming gas bubbles. Your skin would swell to twice its normal size as tissues become distended by water vapor. Worse still, Mars is home to the most intense dust storms ever observed. These storms can cover the entire planet and last for months. The superfine dust particles on Mars, much finer than Earth dust, are statically charged and can easily penetrate fabric layers, damaging equipment. If your spacesuit were punctured by these dust particles, you would face death and despair. Cosmic radiation is also a major threat. Unlike Earth, Mars has no global magnetic field to protect its surface from dangerous radiation from the sun and deep space. Long-term exposure would cause cancer and severe tissue damage. Fourth stop, Jupiter. Now we venture to Jupiter, the giant of the solar system. It is the largest planet, with a mass 318 times that of Earth, and so large it could contain 1,300 Earths inside it. Unlike the first four planets, Jupiter is a gas giant. There is no solid surface to stand on. The journey down into Jupiter is a multi-layered descent into hell. First, you would enter the outer atmosphere, a mixture of hydrogen, about 90%, and helium, about 10%, with small amounts of methane, ammonia, and water vapor. At this level, the temperature is relatively cold, around minus 145 degrees Celsius. You would see beautiful colored cloud bands, white, brown, red, and orange, created by different compounds in the atmosphere. As you descend deeper, you would enter a layer of brownish-green sulfur compounds, where frozen ammonia clouds create strange structures. Here, wind speeds reach an incredible 1,000 kilometers per hour, much faster than any storm on Earth. These winds would toss you up and down violently, spinning you like a leaf in a tornado. You would have no control over your direction, only able to be carried by the flow. Continuing deeper, you would enter the dark zone. Sunlight cannot penetrate this dense atmospheric layer. The temperature begins to rise as the pressure increases. Suddenly, a blinding flash of lightning, 3 times brighter than lightning on Earth, illuminates the darkness around you. It is followed by a deafening thunderclap, so powerful it shakes your entire spacesuit. You have entered the water ice cloud layer, a region filled with relentless electrical discharges and intense thunderstorm activity. As you descend even further into Jupiter's interior, the pressure increases to an unimaginable level. At this depth, the pressure is great enough to compress hydrogen and helium from a gaseous state to a liquid state. You are now swimming, or rather sinking, in an ocean of liquid hydrogen. The temperature here has risen to thousands of degrees. Your suit begins to creak under the pressure. The seams start to deform. Finally, after diving through multiple layers of atmosphere and the liquid hydrogen ocean, you would approach Jupiter's core region. The pressure here reaches a staggering 4,000 gigapascals, equivalent to millions of times Earth's atmospheric pressure. To imagine, this is a pressure over 40 million times greater than at the bottom of the Mariana Trench, the deepest point in Earth's ocean. The temperature at the core reaches 19,700 degrees Celsius, more than 3 times the temperature of the sun's surface, which is only about 5,500 degrees Celsius. In these extreme conditions, a miracle occurs. Electrons are stripped from hydrogen atoms, forming a strange state of matter called liquid metallic hydrogen. This substance is silvery white, reflects light like a mirror, and conducts electricity like a metal, but remains in a liquid state. This is one of the strangest forms of matter in the solar system. By this point, theoretically, you would have died countless times. No man-made material could withstand these conditions. You would be crushed into atoms, then into subatomic particles, becoming part of this ocean of metallic hydrogen. Fifth stop, Saturn. Our fifth destination is Saturn, perhaps the most beautiful planet in the solar system with its famous ring system. Saturn is also a gas giant, similar to Jupiter but less dense. In fact, if you could find an ocean large enough, Saturn would float on water. First, your spacecraft must pass through the iconic rings. From a distance, they look smooth and seamless, but they are actually made of billions of ice and rock particles, ranging in size from tiny dust grains to house-sized boulders. These particles orbit Saturn at tens of thousands of kilometers per hour. A collision with any piece could destroy your ship instantly. After safely passing the rings, you would enter Saturn's outermost atmosphere, a mixture of hydrogen and helium similar to Jupiter. Here, the temperature is a chilling -130 degrees Celsius. The winds here blow at speeds up to 1,800 kilometers per hour at the equator, even faster than Jupiter's. The air around you is a turbulent flow of massive wind currents, creating cloud bands that stretch for thousands of kilometers. Continuing deeper, you would reach the bottom of the ammonia cloud layer. Here, ammonia freezes into sparkling crystals that float in the dense air. You then enter a dark brown layer of sulfur compounds, creating an unpleasant smell of rotten eggs. If your suit had a leak, this smell would be nauseating, but of course, that would be the last of your worries. The deeper you go into Saturn, the more terrifying the environment becomes. Huge static charges build up in the clouds, creating giant electrical discharges, lightning bolts much more powerful than those on Earth. Continuous lightning strikes would explode around you, each flash as bright as day, blinding you before plunging you back into darkness. The pressure and temperature increase relentlessly. Continuing deeper, you would approach the core region, a central mass surrounded by dense layers of hydrogen and helium. The pressure and density here becomes so immense that it begins to slow your descent. Like sinking in honey, every movement becomes more difficult as the surrounding medium thickens. At greater depths, as temperature and density continue to rise, a strange phenomenon occurs. The immense pressure compresses hydrogen gas into liquid metallic hydrogen, just like in Jupiter's interior. At this stage, you would endure a pressure equivalent to 1 million times Earth's atmospheric pressure. No material could survive. Your suit would be flattened like paper, then crushed into individual atoms. Finally, you would reach Saturn's core. Scientists believe this core may be a solid or semi-liquid mass of rock and ice, about 10-20 times the mass of Earth. The temperature here reaches about 11,700 degrees Celsius. The pressure and density would exceed anything we can calculate or measure with any technology we have. If you somehow remained intact to this point, which is completely impossible, you would be instantly crushed into subatomic debris. An interesting fact is that Saturn radiates more energy than it receives from the Sun, about twice as much. This excess energy comes from liquid helium raining down through the metallic hydrogen layer, creating friction and heat. Sixth stop, Uranus. Next on our journey is Uranus, an ice giant with many strange features. It is the only planet that rotates almost completely on its side. Its axis of rotation is tilted at 98 degrees, meaning it rolls around the Sun instead of spinning like a top. The first thing you'll notice about Uranus is the terrible smell. Hydrogen sulfide, H2S gas, the substance that creates the smell of rotten eggs, has been confirmed by scientists to be in the planet's upper cloud layer. This is a toxic gas, and inhaling it would be fatal. But breathing would be the least of your problems when facing the other harsh conditions. The temperature in the upper atmosphere of Uranus drops to -220 degrees Celsius, making it the coldest planet in the solar system, even colder than Neptune, although Neptune is farther from the Sun. The reason for this extreme cold is still a mystery to scientists. The winds on Uranus, though not as fast as on Neptune, still reach speeds of up to 900 kilometers per hour. High-speed ice and rock particles in these winds would gradually puncture your spacesuit like thousands of tiny needles constantly pricking you. But the truly magical and deadly phenomenon occurs deep inside Uranus. At a depth of about 10,000 kilometers below the cloud tops, the pressure increases to millions of times Earth's pressure, and the temperature rises to thousands of degrees Celsius. In these extreme conditions, a miracle happens. Carbon atoms are stripped from methane and other organic compounds, and then the enormous pressure and temperature force them to crystallize into diamonds. These are not small diamonds. They can be as large as pebbles or even larger, and they fall like rain through the dense atmosphere. Scientists call this phenomenon diamond rain, and it has been confirmed through experiments simulating the conditions inside ice giants. Every year, up to 1,000 tons of diamonds may rain down inside Uranus. Your spacesuit would be unable to protect you from this pressure. And your body, which is primarily based on carbon in your DNA, in your proteins, in every cell, would ultimately suffer the same fate. Under this horrific pressure, the carbon in your body would be stripped away and crystallized. You would slowly turn into a diamond, compressed by an irresistible force. It would be a strange and terrifying death, becoming part of an eternal diamond rain. Final stop, Neptune. Our final stop is Neptune, the farthest planet from the Sun in the solar system, since Pluto was downgraded to a dwarf planet. It is so far away that a year on Neptune lasts 165 Earth years. Sunlight takes more than 4 hours to reach it, and from Neptune, the Sun looks like just a bright star in a dark sky. First, you would reach a thin layer of cirrus clouds about 10 kilometers thick, made up mainly of frozen methane and hydrogen. The methane in the atmosphere is why Neptune has its beautiful deep blue color. It absorbs red light and reflects blue light. The temperature in this cloud layer drops to minus 200 degrees Celsius, cold enough to freeze any gas on Earth. Just 10 minutes after entering the atmosphere, you would descend into a layer of hydrogen sulfide clouds with their characteristic foul smell. The pressure here begins to increase, reaching nearly 5 times Earth's standard atmospheric pressure. But the most terrifying thing is the wind. Neptune has the strongest, fastest winds in the entire solar system, with speeds up to 2,100 kilometers per hour, nearly twice the speed of sound. These are winds faster than any commercial jet. The strange thing is that Neptune is 30 times farther from the Sun than Earth and receives only 0.1% of the solar energy that Earth does, yet it has the most powerful storms. Scientists believe the energy primarily comes from within the planet. Neptune radiates 2.2, 6 times more energy than it receives from the Sun. This heat source creates powerful convection, leading to these terrible winds. These winds would toss you around like a leaf in a tornado. You would spin at an uncontrollable speed, crashing into dense air currents with tremendous force. There is no way to stabilize or navigate in this chaotic environment. Continuing your descent, after about an hour, you would be plunged into complete darkness. Not a single ray of sunlight can penetrate this thick atmosphere. You float in a completely black world, hearing only the sound of the fierce winds howling around you. Suddenly, a giant lightning bolt unexpectedly tears through the darkness. The blinding light illuminates an entire region of the sky, revealing that you have entered the water ice cloud layer, an area of the most intense thunderstorm and storm activity. The lightning on Neptune is much more powerful than on Earth, each strike capable of being as bright as thousands of headlights. Thunder rumbles continuously, creating a terrifying symphony of nature. After about 2 hours from entering the atmosphere, you reach the bottom of the water ice cloud layer. Here, conditions become truly hellish. Your suit would need to withstand pressures over 10,000 atmospheres, equivalent to the pressure at a depth of 100 kilometers under Earth's ocean, much deeper than any existing ocean. Meanwhile, the temperature soars to over 2,000 degrees Celsius. Your suit would be simultaneously compressed and heated. The metal would start to warp and the seams would begin to melt. Continuing deeper for 3 more hours, as you begin to approach Neptune's core, the conditions surpass human imagination. The pressure becomes too great to be measured by any technology we have, possibly reaching millions of atmospheres. The temperature rises to nearly 7,000 degrees Celsius, hotter than the surface of the Sun. In these extreme conditions, matter behaves in strange ways. Methane and ammonia ice, normally solid and cold substances, here behave like super-hot liquids, flowing and swirling under immense pressure. Carbon atoms are stripped from methane and, like on Uranus, are forced to crystallize into diamonds under the horrific pressure and temperature. However, on Neptune, the diamond rain phenomenon is even more intense. Thousands of tons of diamonds fall each year, forming larger, heavier diamond particles as they absorb more carbon during their fall. The closer to the core, the greater the density of diamonds. The diamond rain becomes a diamond blizzard. Billions of large and small diamonds fly around in this super-pressurized environment, colliding with each other, creating a fantastical sparkling light in the darkness. After about 5 hours of descent, you continue to sink deeper into this diamond blizzard. The pressure is now great enough to compress diamonds into larger masses. Perhaps there are even giant diamond icebergs floating in this ocean of superhot liquid. Finally, after about 7 hours from entering Neptune's atmosphere, you will reach the center of the planet, a sight unlike anywhere else in the solar system. Neptune's core is believed to be a solid mass of silicate rock and heavy metals like iron and nickel, with a mass of about 1 to 1.5 times that of Earth, but compressed to an extremely high density. Surrounding this solid core is a unique ocean, not ordinary water, but a super hot, super pressurized mixture of water, ammonia, and methane. Scientists call this mixture hot ice or superionic ice, a strange state of matter where water remains a liquid despite a temperature of thousands of degrees because the immense pressure prevents it from vaporizing. In this state, water molecules are broken apart and free hydrogen and oxygen ions move around, creating an electrically conductive liquid. Here, at the center of Neptune, under immeasurable pressure, at a temperature of 7,000 degrees Celsius, surrounded by an ocean of superionic ice and an eternal diamond blizzard, you will be laid to rest. Your body would have long been crushed into atoms. Perhaps some of the carbon from your body would have also crystallized into diamonds, becoming a permanent part of this planet. This is the end of this perilous journey through the solar system, a voyage from the fiery worlds of Mercury and Venus through the frozen world of Mars to the gas and ice giants where matter exists in the strangest forms. Each planet is a hell of its own, with unique ways to end a life.